Polynomial graph and behavior, Algebra 2 Common Core. So just to jump ahead on this sheet a little bit, I want to point out something that this is going to be the confusing part. That there's a difference between something being an odd, even degree and an even function. Odd degree, odd function. And so what do we talk, what's the difference between degree and function? Well, in even degree, the rule for even degree is your highest exponent is even. So the highest exponent is even. That's it. And the rule for odd degree is the highest exponent is odd. And I'll go back to those sketches we want to do in a second, but no matter what, equation you're looking at the graph of, it's going to be even or odd because what's the highest exponent? It could be a 1, a 2, a 3, a 4. It's going to have an exponent unless it's just a, y equals 5 constant kind of thing. That's the one example that kind of doesn't fit there. But everything we're going to see with polynomials, polynomial implies it has multiple, you know, um, terms to it. Poly means many. So it's going to be even or odd, degree. But an even degree graph does not necessarily mean it is an even function graph. When we talk about the word function for these types of graphs, what we're really referring to is a type of symmetry. So these are symmetry things. And I'll get to what type of symmetry in a minute. So symmetry, and I'll fill in something in front of it for even function, odd function. Now, even degree just means the highest exponent is even. Odd degree means the highest exponent is odd. An even degree can be an even function, but it cannot be an odd function. So you can't have a graph that's even degree odd function. There's no crossover here. If the highest exponent is even, then it might be an even function, or it might be what we call a neither. Like it's not odd, even, or neither is really what we ask as far as function goes. The same goes for odd. If it's odd degree, then the only option is odd function or not. Can't be even. But let me get into what this is all really talking about. So first thing we want to do is just kind of look at some of these sketches here. And I'll tell you right now that these first three graphs are all even degree graphs. These are all even degree graphs. The highest exponent is even. The highest exponent is 2, highest exponent 4, highest exponent is 3. All three of these graphs are even degree graphs. So let's go ahead and take a look at each of these in our calculator and see what they have in common and what's different than them. So first, the typical x squared graph that you, I'm sure, know what it looks like. It's just a basic parabola. It's got one root bouncing at 0. So one root multiplicity 2. We would say x equals 0 multiplicity 2. And y equals x to the 4th. Keep that in there. Also only has one root of 0, but it's multiplicity 4. So you're going to see it bouncing there. Now one thing that happens is as the multiplicity gets higher, it tends to kind of look like it's flattening out at the location of the root. If I zoom in a little bit to give you a better view of that, you'll see it kind of looks like there's your x squared graph, and then here comes the x to the 4th graph. It almost looks like it's riding the x-axis a little bit. But if you keep zooming in here, it's not. It really is only hitting at the origin. It's just getting very close to it, hitting the origin, staying very close, and then bouncing out. So it kind of flattens a little bit with the higher multiplicity. And then we could take a look also at the graph x to the 6th plus x cubed. Math 3 is a shortcut to get a 3 exponent. And let me look at that now. Stay zoomed in, and you're going to see it coming here, and like that. So first, what do all these graphs have in common? First, let me zoom out and do this here. You're not going to actually see me draw the graphs here because it's hard to draw with precision with this tablet that I'm writing on. So you can do these sketches yourself if you'd like. But I'm going to drag this picture over so we can take a look at it in a little bit more detail. But what are you noticing here? Well, one thing you should notice is that for x squared, the graph on the calculator doesn't put arrows on the ends for you, but where would the arrows go? They would go here, 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 and here. Notice that they're all pointing in the same direction. Like for the x squared, both arrows are pointing up. For the x to the fourth, both arrows are pointing up. For the x to the sixth, both arrows are pointing up. And that's the other thing about even degree, is that the arrows are together. So the rule for even degree is the highest exponent is even, and the arrows are together, meaning they're pointing in the same direction. It doesn't necessarily mean both pointing up. It could also mean they're both pointing down. All right, now let's take a look at the odd degree functions. Odd degree. And that means simply that the highest exponent is odd. This is y equals x, which is the same thing as to the first, x to the third, odd, x to the fifth. And you could probably guess what's going to happen here without me even doing this work for you. With an even function, the arrows all point in the same direction. With an odd function, they're all going to point in opposite directions. But let me get you these pictures here. I'll show you what I'm talking about. So let's delete the ones in here that we had. And we'll just type y equals x in the first one. Oops. Y equals x. Y equals x to the third. Y equals x to the fifth minus x squared. All right, so zoom, 6, get all these graphs here. So here's y equals x, and again, you see the arrows pointing in opposite direction. One's pointing down, one's pointing up. Here's the x cubed, one's pointing down, one's pointing up. And the x to the fifth minus x squared. Same situation. Again, if I drag this over here, and you could do these sketches. But the thing I'm really trying to point out here is that the arrows are not pointing in the same direction for these graphs. They're pointing in opposite directions, and that's what an odd degree is. If your highest exponent is odd, the arrows are in the opposite direction. Sometimes we say arrows apart. So that's what's happening there for even and odd degree. It's very simple. Looking at an equation, it's just what's the highest exponent. Looking at a graph, are the arrows pointing in the same direction, or are they pointing in opposite directions? So this is talking about even and odd degree, but what this is further getting into is talking about the lead coefficient. And the lead coefficient is whatever the coefficient is of that highest exponent. So if you have, 7x squared plus x minus 3, this would be a even degree because the highest exponent is even, and the lead coefficient would be 7. If you had a different one of y equals 8 minus x plus x squared minus 3x cubed. The highest degree is 3, so this is an odd degree, and the lead coefficient is negative 3 because it's the coefficient of the term that has the highest degree. So it's not always in the front. That is why I kind of did that one backwards. Now, even degree, we already said the arrows point in the same direction, either both up or both down. Now, how can we tell sometimes when it's up and down? That has to do with the lead coefficient. If you have a positive lead coefficient, they're going to be pointing up together. A negative lead coefficient, they're going to be pointing down together. Sometimes we say smiley face, frowny face. So like this is y equals x squared, and this is y equals negative x squared. Now for the odds, we said the arrows are pointing in opposite directions. And that's true whether it's an even, a positive, or negative lead coefficient. Really what happens when you have a negative lead coefficient is you just reflect the graph over the x-axis. That's how you get these. But the thing to remember for positive and negative lead coefficients, a positive lead coefficient ends up. So like it ends to the right is going up. Positive lead coefficient. If you see the right arrow pointing up, it's got a positive lead coefficient, and a negative leading coefficient ends down. So we see that the right arrow is pointing down. The right arrow is pointing down. So you can just take a look at how the graph is ending to the right. Is it ending up, ending down? Ending up, the lead coefficient is positive. Ending down, it is negative. Now let me explain a little bit what all this stuff is talking about. It's basically talking about the end behavior of these graphs. as x, this little arrow, we say the word approaches. So as x approaches infinity, f of x, which is the same thing as y, approaches infinity. Now when x approaches infinity, positive infinity, what we're talking about is going to the right. As x approaches negative infinity, we're talking about going left. And so what this is saying is as x goes right, approaches infinity, the y value also approaches infinity, but y approaching infinity is up. I mean, think about your x and y axes. The x-axis, as it goes to infinity, is going to the right. As it goes to negative infinity, it's going to the left. The y-axis, as it goes to infinity, is up. Going to negative infinity is down. So what we're saying here, and this is, this is for this graph right here, that as we go right, we go up. As we go left, we go up. So as x goes negative infinity left, f of x goes up. How about this one? As x goes to infinity, so as we go right, f of x goes to infinity, up. As x goes to negative infinity, left, f of x goes to negative infinity, down. As we go right, we go up. As we go left, we go down. And then when you have a negative lead coefficient, that stuff kind of changes. So as we go right, we go down. As we go right, we go down. As we go left, we go down. As we go left, we go up. So they're all a little bit different. So this has all been talking about the degree and lead coefficient and stuff like that. So that's the even degree, odd degree, and how they behave, and how the sign of the lead coefficient affects how, which direction it's ending and stuff like that. What about even and odd function? As I mentioned, that has to do with something called symmetry. And you've learned about symmetry in geometry. There's two types of symmetry. There's reflection symmetry, like a mirror image, and then there's point symmetry, where like it looks the same upside down. I can rotate it 180 degrees and it looks the same. Well, for a graph to be considered an even function, first of all, the graph has to have an even degree. And not only that, it has to be symmetrical about the y-axis. See how this is a mirror image on the y-axis? So we call it y-axis symmetry. That's what an even function graph has to have, y-axis symmetry. So like if we went back to these graphs over here, you notice that these first two have y-axis symmetry, but this last graph, and if I just type in that last graph to kind of illustrate my point here, this last graph is an even degree, but it is not an even function. X to the sixth plus x to the third. Right? And you'll see why. Now the arrows are pointing in the same direction. It is an even degree because the highest exponent is even, but it is not an even function. And I'll show you what I mean when I zoom into the graph. It's hard to tell when you're zoomed out. But you'll zoom in here, you'll see that it's not a perfect mirror image because this one kind of dips down, but it doesn't dip down over here. It's not a perfect reflection of itself. So this is an even degree, but not an even function. And the same thing happens for odd. This was an odd degree, this was an odd degree, but this was not. Now it's not y-axis symmetry. Odd functions have origin point symmetry. And what that means is they look the same if you flip it 180 degrees upside down. Let me show you an example here. Like here, this if I trace out this curve, and I do it well, try to trace this curve here, and if I then can click that and spin it 180 degrees, oh, I grabbed the wrong thing, but it worked. It still falls perfectly on itself. That is rotation symmetry, point symmetry. And that's what an odd degree has, but it has to be rotating about the origin to work. So looking at the graphs, something like x cubed, this has point symmetry. It's a perfect 180 rotation of itself there. But if I simply do a plus 2 on the end of that, and I'll go back to a zoomed out view, you'll see that it's still an odd degree. The arrows are still pointing away from each other. The highest exponent is still odd, but it doesn't have that rotation symmetry anymore. If I rotate it about the origin, part of the graph will cross here, not here. It doesn't look exactly the same. So the rule for even function is y-axis symmetry. Odd function is origin symmetry. And y-axis symmetry is a type of reflection, where origin symmetry is a type of rotation symmetry. So is it mirror image or the same upside down. But you'll see graphs that are neither, like this graph right here. It's, if I ask the question, is this odd, even, or neither function? The answer is neither. It's an odd degree, but it's not an odd function. Now, how can you tell this just by looking at the equations? It's actually pretty easy. By looking at the equations, an odd function has, I'm sorry, an even function has all even exponents. An odd function has all odd exponents. The one exception here is that even functions they don't have to, so I should say can include constants. Meaning, all right, x to the fourth, that's even, x squared, that's even, minus 6x to the eighth, that's even, plus 5. Now, 5's an odd number, but what's its exponent? You could think of it as x to the 0, which can be considered even. Now, we don't really say 0 is an even number, but in this case, constants are allowed for even functions, not for odd functions. For odd functions, it has to be all odd exponents, no constants. All right, so looking at these graphs here, determine if it's odd, even, neither, and determine the lead coefficient sign. So this first graph, the arrows are both pointing up, so it is an even degree, but is it an even function? I see some y-axis symmetry. Yes, I believe this is an even function. The second graph, the arrows are pointing away from each other, so it is odd degree, but is it an odd function? Rotate about the origin. Yes, this is an odd function. The third one, similar to the graph I showed you on the calculator. Arrows are pointing away from each other, so it is odd degree, but it would be considered a neither function. How about from equations? Here, I have an odd exponent. That counts as x to the first. That's an odd exponent. All odd exponents are odd functions. Type it in. It'll look something like this. Next one. I see even and odd. That is neither. This would be odd degree, but a neither function. And this, even exponent, constants are allowed. This is an even function. Last thing I want to do with you here is match the graph. And we're going to try to do this without a graphic calculator. This is actually running super, super long. Sorry about that. This is a pretty complex lesson here. So I'll tell you what, maybe we'll do this in class. I didn't realize how much time I was using here, and we'll talk more about this in class. See ya.